Okay, this will be a short video that will be for Stat 210. It's going to be on handout number 6, pages 14 through 19. So let's go ahead and get started. Okay, on page 14 then, what we are doing with this particular example is to just continue with this idea of understanding variation in repeated samples, where I have several different proportions that I'm interested in, or several different parameters that I'm interested in, but the proportions are not going to all be the same, or the parameter values are not going to be all the same. So one advantage that we had in the previous example is that the pyramids were all stacked on top of one another. In this particular case, they're not going to be. And this has to deal with data from the Minnesota Student Survey. The Minnesota Student Survey is a survey that is administered to middle school and high school students throughout the state of Minnesota. This survey has lots of different questions on it, and the question that I'm going to be looking at is question about marijuana use, by students in middle school. In particular, I'm going to be looking at 6th graders. And I'm going to put the focus on just students from Fillmore County as well. Fillmore County is the county where my children go to school, in Rushford, Minnesota. So that's in Fillmore County. Okay, so this question is about risk. And again, I'm going to be working with how much do you think people risk harming themselves physically or in other ways if they smoke marijuana once or twice per week. The students are asked to select either great risk, moderate risk, slight risk, or no risk when doing this. If I get data from Fillmore County, looks like table 39 here, I'm able to, they actually break it out by different grade levels here, and they're also breaking it out between males and females. I'm not going to worry about differences between gender here, but I am going to be working with grade 6, as I said. So how many total people thought smoking weed in 6th grade was of no risk? I had 9 people there. I got 4 males and 5 females, so 9 total. So that's going to be my data value there for no risk. How about slight risk? Going to have 9 again. For moderate risk, so those that selected moderate risk, I had a total of 20. And those that selected great risk, I had a total of 68 plus 75. So how many is that? 68 plus 75, 143 in that group. So my data here is going to be 9, 9, 20, and then 143. Okay, let's move on to page 15. I'm going to need to build a reference distribution here. So let's just go back up here. Sorry about that. I'm going to need to take my observed data, which again was 9, 9, 20, and 143, and compare that against some sort of situation. Now, what we did before is compared it against a situation that everything was kind of equally distributed across the 4 groups. In this particular context, I'm not going to compare it across equally distributed. We're talking about 6th graders here. I hope that a larger proportion of those think smoking weed's great risk than no risk at all. And certainly the data reflects that as well. So I would anticipate that many more students, especially in 6th grade, are going to think smoking weed is of great risk. So here I'm going to compare these values against the historical trends for the state of Minnesota. And those historical trends are the following here. About 3 out of 4 students in grade 6 respond that smoking weed once or twice per week is of great risk. Okay, so about 75%, right? 3 out of 4. So the great risk category, I would expect to have about 75% in this group, if the children from Fillmore County are following the trends across the rest of the state here. Let's go ahead and highlight that. Expect to have about 75% in the great risk. Only about 1%, okay, so a very small proportion, think smoking weed's of no risk at all. And then it says that the remaining typically divide themselves between the other 2 categories, the slight risk and moderate. So if I have 75 and 1, that's 76. 76, 1 minus 100% minus 76 is 24. 24 divided by 2. So about 12% in each of these categories. So let's just go ahead and highlight that as well. So this is how I'm going to compute my expected quantities now. And this is where the pyramids are going to be centered. For the great risk, the pyramid is going to be centered 75% of the way up the number line. For no risk, it's only 1% of the way up the number line. And then for slight and moderate, I'm going to have them stacked on top of each other at about 12% of the way up the number line. So there's my research question stated there in the middle of page 15 there. Is there evidence to suggest that grade 6 students from Fillmore County deviate from the historical patterns in regard to the marijuana portion of question 105? I'm going to have, again, 4 different parameters. So I'm going to have a percentage or probability for a parameter for grade 6, with no risk. So that's actually going to be set to 1% under the null hypothesis. The proportion for slight risk is going to be set at 12%. So we can go ahead and fill these in on page 15. No risk should be 1%. Slight risk is going to be 12% here. Moderate risk is going to be 12%. And then great risk is going to be that large proportion, or 75%. And the alternative hypothesis is that one of these, at least one of these, is off from that proportion from the historical trends. Okay, so we can compute the expecteds. So using those same things, computing the expecteds. Again, my observed data here, so maybe highlight those. My observed data here is the 9, 9, 20, and 143. And then the expected data is what those numbers should look like if they're following the historical trends for others across the state of Minnesota. And again, where are these coming from? So where is this 181 coming, 1.81 coming from? It's coming from 181, which was my total number of children surveyed, times that 1%. Because again, 1% of the students, if we go back up here and look at the parameter value, 1% of the students should be in the no-risk group. So where's the 21.72 coming from? Again, the 181 times the 12%. Now that's the same for the moderate, because both of those were at 12%. And then finally, the proportion for the great risk category is going to be somewhat larger at 181 times, 75%, right? So that's where those expected quantities are coming from. Again, those expected quantities and also the reference distributions are going to be obtained or computed under the null hypothesis. I will let you answer those questions there on page 16. So let's look at the framework for a simulation here on page 17. I'm not actually going to do this. I could do this simulation again in JUMP, just like we talked about in the previous video. But again, I'd be building a hat here. 75% would be great risk, equally divided between the 12% for moderate and slight risk. And then a very skinny part of my hat, only 1% is going to be for no risk. I reach in my hat and I pull out 181 observations. And I do that a whole bunch of times in order to build my reference distributions. Now the great risk category, again, should have a large number in them, 75%. So for the great risk category, we're 75% of the way up that number line. On the no risk category, though, we're only 1% of the way up the number line. And one thing that we notice when these proportions differ across the different categories is that some of these reference distributions are very skinny, like here for no risk, and others, okay, are not skinny at all. They're somewhat wide here. They vary from 120 all the way up to 150. So they vary quite a bit here for the great risk, but they don't vary very much at all down here for the no risk. So one side effect of these parameters being different is that the widths of these reference distributions are going to vary. Now, we didn't have that problem before when we were looking at the previous example with the crime rates around the University of Minnesota, because all four pyramids were located at the same spot. So let's just do a real quick check here. My observed data for no risk, I believe, was 9. 9 certainly looks like it's an outlier in that picture. So no risk, yeah, that's an outlier. How about for slight risk? Again, 9 looks like it's going to be an outlier in that one. It's on the lower side, so that's going to be a yes, that's going to be an outlier. So that'll have an X there. How about moderate risk? I think the observed outcome for moderate was at 20. 20 is right in the middle of that pyramid, so that's not going to be an outlier. And then great risk here was at 143, I think it was, if I go back up and check. Yep, 143. So 143 here is not an outlier. So here's a situation where I have, for two groups, I'm an outlier, an actually pretty extreme outlier, and then for the other two groups, I'm not. So we're going to have to struggle again with this. I need to condense this down into a single number in order to make a reasonable decision about the single research question that was being asked. Now, let's go ahead and do that. So that's what's on page 18 here. So if we look at page 18, the table on the top of page 18, I'm just going to go ahead and compute the observed minus the expected. Okay. And then I would actually need to square this as well. So what we're actually going to do to compute these things is actually square those. So maybe I should insert another row in this table and just make that really obvious. What we end up doing is taking those observed minus the expected and square them. So in the end, we're going to end up taking this 7.19 and squaring that quantity, whatever that turns out to be. Here I'm going to take that negative 12.72 and I'm going to square that quantity, whatever that turns out to be. This one's right on target, negative 1.72, so that's not very far off at all. I'm going to square that. Oops, negative 1.72, I'm going to square that. And then here I'm going to take 7.25 and square that, and I'm going to get a value as well. So if we just kind of proceed with what we were doing in the up above, I would just take each of these distances and square them. But before I do that, let's just look at these two quantities here and the no risk and the great risk. I believe we said for the no risk that 9 was indeed an outlier compared against 1.81. So if we go back up and look at those reference distributions, for the for the no risk group, 9 is very much an outlier. And if we look at how far off is 9, okay, so 9 minus its expected, which is 1.81 here. 9 minus its expected is about 7 off. So in this particular pyramid, or in this reference distribution, being 7 off is actually quite a bit. However, when I go look at the great risk group, okay, the great risk group had an expected quantity of 135.75. The observed outcome was 43. This one also is about 7 off. In fact, it's actually a little bit more than this one over here in the no risk. So this 7 over here is an outlier. Okay, but this 7 over here is not an outlier. And the reason that's happening is because the pyramid for the great risk is a lot wider than the pyramid for the no risk group. Again, if we go back up there and look at those pyramids, we can see that being 7 off in this pyramid, the great risk pyramid is not that big a deal. But because this pyramid down here at the no risk, okay, this reference distribution is so skinny, being 7 off here is actually a very big deal. So right now, our way of condensing the information does not take that into consideration. We need to be a little bit careful, more careful about how we do our condensing. This 7 here, okay, needs to take into consideration the fact that the expected is actually pretty small in this case. And over here, being 7 away is not that big a deal because this expected is so big. So what we do to fix that, and this is what is our standard test statistic for a chi-square test, is that we end up taking that. So what we have been doing, okay, up to this point, what we have been doing is just looking at the observed minus the expected, and then we squared that. We squared that in order to get rid of, okay, the negative effect or the canceling out effect. But we're going to add one more component to that, and that is to divide by the expected. And again, that puts that distance, that squared distance, kind of puts it in perspective for me. It's relative to where I'm kind of starting from. And then I'm going to compute that thing, okay? I'm going to go ahead and compute that quantity for each of the different categories, and then I'm going to add all of those up. And this is indeed what is called the chi-square test. So if we do a wiki search on calculate a test statistic, okay, or do a wiki search for a chi-square test, that's what I have here, you can see that the test statistic has the following form here. The O stands for the observed. The E stands for the expected. I'm going to difference those, square them, and then I'm going to divide by the expected. And I'm going to add up all of those across all of the categories. And that's at the heart of the chi-square test. That's at the heart of the chi-square test. So let's go ahead and do that for this data. So here I'm taking the observed minus the expected. I get a value of 7.19. I'm going to square that, so I get 51.7. But now I'm going to take this, so how we're getting this 28 value is I'm taking that 51.7 and now dividing it by the expected. And when I do that math, I get that 28.56. So I just need to take those observed minus expected squared quantities and divide them by the expected. So this is going to be 161.8 divided by 21.72. And when I do that math, I get about 7. Now this, for the, was it moderate here? They were actually really close to the expected, so I'm going to take 2.96 and divide by the 21.72. That's going to be very small there, 0.14. And again, all that's saying is that 0.14 is just saying, you know what, your observed and your expected are really close together here. The only way that I'm going to get 0 in this calculation, if we go back here and look at this, the only way I'm going to get 0 is if the observed and the expected are right on top of one another. Now let's go ahead and look at what happened over here with the great risk group. That 52.56 is going to have to be divided by 135.75. And again, once I do that divide by that large quantity, that distance of 7 actually becomes quite small. So clearly and then of course I add all these up. So I take the 28 plus the 7 plus the 0.14 and 0.39 and I get a value of 36. So now this again is going to be my, if you let me put quotes on it, kind of my data value. And what this 36 represents is kind of how far away are you from the expected across all 4 categories here. Now we actually do some squaring in there. Again, we're doing the squaring to get rid of the negatives. We actually do some divide by expected. We need to do that to kind of put that squared distance in perspective a little bit of what we mean by a large distance. That's why we're dividing by the expected there. But once I get all of my information down to a single value, I can go ahead and build my reference distribution just like I did before. Okay, so my data value here, my data value is going to be 36.54, and I just need to figure out whether or not I'm going to be large, whether or not this is an outlier compared to what would happen under the situation of this one is under the situation that they are like the historical patterns. So the children in Fillmore County are like the historical patterns. And again, the smallest possible value here is 0. I can't have any negative values on the chi-square distribution. And this chi-square distribution is going to have, again, kind of a big hump at the beginning, and then it's going to trail off or skew kind of to the right on the right-hand side. Now, these are going to be, in the previous example, I think I had values in the hundreds. I think my observed outcome was 137, and I was getting values around 300. The chi-square distribution actually has values somewhat smaller than that because, again, I'm dividing those distances by the expected. Okay. So the goal still remains I need to determine whether or not 36.54 is an outlier. I'm going to determine the p-value is going to be anything that is bigger than that 36.54. Again, we just go to the right-hand side there. Values away from 0. Okay, so 0 means they're on target here. And values way up here on the other end mean we're off of our target. And here, I guess I'm talking about off of target from our historical patterns. Off of the expected here. All right, I think I'm going to pause here because I want to show you another video here of how to get this done in JUMP, but I think this is a natural place to break. And then I will make a third video here and show you that as well. All right, thank you. See you in a minute.